Okay, Assalamualaikum, good morning, good afternoon, and good night to the people that are currently watching, especially to Sir Muhammad Ashrul. Okay, so we are group T5CS1102F, and today we will be presenting our object-oriented program project called Student Attendance System. So my name is Muhammad Faris Akmal bin Kamarul. Together with my teammate Adam Mikael, Muhammad Irfan, and Muhammad Anis Fazila, we developed this system using Java by applying object-oriented programming concepts. Okay, so without further ado, let's begin our presentation. So let's get to the organizational structure. So this is our chart organization. I, Muhammad Faris Akmal bin Kamarul, is the group leader, following with Programmer 1, which is Adam Mikael bin Borhan, Programmer 2, Muhammad Irfan bin Daud, and Programmer 3, Muhammad Haris Fazila bin Nazri. So before I begin, I would like to inform you that one of our group members, Muhammad Haris Fazila bin Nazri, has been transferred to another university and therefore unable to participate in today's presentation. Okay, now let's get to the job description. So the group leader, me, Muhammad Faris Akmal, is responsible for generating ideas and directs team members on what task needs to be done and how to do it. Other than that, get opinions from team members and determines the best solution, and monitor and helps with every activity and task performed by the team. Okay, so what is the task of Programmer 1, which is Adam Mikael? He translates ideas into codes, so my ideas into codes, execute precise implementation of object-oriented programming, and is responsible for every coding sections. Okay. Next, Programmer 2, which is Muhammad Irfan, assists in programming activities, check for errors in the system, and responsible for the end result for the system. And for Programmer 3, Muhammad Fazila is responsible for testing the program and ensuring usability, creates user guide, code documentation, and system manuals, and lastly, ensures smooth experience for the system. Alright, that's it for the job description. Okay, now let's get to the overview of the introduction. Alright. So student attendance plays an important role in helping lecturers monitor students' participation and commitment in class. However, many institutions still rely on manual attendance, recording using paper or spreadsheets. This process is slow, inefficient, and can easily lead to mistakes. To solve this problem, we developed the students' attendance system using Java and object-oriented programming. Our system allows lecturers to record attendance digitally, automatically calculate attendance percentages, and generate organized attendance reports, making the attendance management much faster and more accurate. Alright, 2.2 current operational process. Before our system was developed, attendance management had several weaknesses, causing several problems. Firstly, attendance was recorded manually using paper or spreadsheets. Secondly, attendance records were difficult to organize and manage. Thirdly, attendance percentage had to be calculated manually. In addition, lecturers spent extra time preparing attendance reports. Finally, human errors such as incorrect calculations or missing records occurred frequently. These issues has motivated us to create a better attendance management system. Okay, 2.3 proposed process. Our proposed system automates the entire attendance process. Firstly, the lecturer can register new students into the system. Students are able to perform self-check-in to record their attendance. If a student is absent, the lecturer can report the absence. The lecturer also has the authority to override attendance records whenever necessary. Besides that, attendance sheets can be viewed instantly, and the system automatically generates attendance performance reports. Overall, these features reduce manual work while improving accuracy and efficiency. Alright, next, 2.4 calculation formula. Our system automatically calculates each student's attendance percentage using this formula. Attendance percentage equals to class attended divided by total class multiplied by 100. For example, if a student attends 18 out of 20 class, the attendance percentage will be 90%. The calculation is updated automatically whenever the attendance records are modified, so lecturers do not need to calculate anything manually. Alright, so let's get to the objectives. The student attendance system are created with 5 main objectives. First, to develop a Java-based attendance management system using object-oriented programming concepts. Second, to allow users to record student attendance by entering student names, student IDs, and attendance status. Third, to automatically calculate and maintain the attendance record for all students. Fourth, to calculate and display the overall attendance percentage accurately. And the last one, 5, to generate a well-organized attendance report that can be easily viewed and analyzed. Alright, so let's get to the scope of our project. 4.1 UML class diagram. The student attendance system consists of 4 main classes. Number 1, student attendance. Student attendance class acts as a superclass containing common student information and attendance calculation methods. Second, the regular student attendance class inherits from student attendance and stores additional information such as home state and emergency contact. The third one, international student attendance. So international student attendance class inherits from student attendance and stores visa expiry date and passport number. And the last one, the attendance list class aggregates student attendance objects and manage attendance records. 4.2 actor. So the student attendance system consists of one actor, which is the lecturer. The lecturer is responsible for managing student attendance records and performing all attendance-related operations within the system. The lecturer can register new students, record or update attendance information, view attendance sheets, monitor class performance, and manage attendance records efficiently. Next, 4.3 use case diagram. The lecturer performs the following use cases. Number 1, register a new student. Next one, self-check-in. Number 3, record absence, attendance override, view attendance sheet, and then lastly, view class performance. So next, 4.4, class relationships. This slide explains the relationship between the classes in our system. The first relationship is inheritance. Both regular student attendance and international student attendance inherit from student attendance superclass. This allows both subclasses to reuse common attributes and methods such as student ID, student name, attendance recording, and attendance percentage calculations, while also having their own additional attributes. The second relationship is aggregation. The attendance list class aggregates multiple student attendance objects. In other words, one attendance list manage a collection of student attendance record, while each student attendance object can still exist independently. Lastly, in the use case diagram, there are two important relationships. Self-check-in has an include relationship with register new student, meaning a student must be registered before they can check in. Report absence has an extend relationship with self-check-in, meaning reporting an absence is an optional action that extends the normal attendance process. These relationships demonstrate the use of key object-oriented programming concepts in our student attendance system.
Hi, my name is Muhammad Irfan Daud. Today, I will walk you through the system design and class implementation of our student attendance system. Let's start with our UML diagram. Our system is built heavily on core object-oriented programming (OOP) principles. At the center, we have student attendance, which is an abstract superclass containing shared attributes like student ID, student name, total class, and class attendance. We achieve inheritance by splitting this into two distinct subclasses: international student attendance, which track visa expiry dates and passport number. 2. We have regular student attendance, which track the student homestay and emergency contact details. Both subclasses utilize method overriding for generate status report to handle their specific business logic. Finally, we use aggregation to link this to our attendance list class, which hold an array or array list of the student object to manage the overall class data. Moving to the use case diagram, our primary actor is the lecturer who can register new student, execute self-check-ins, report absence, override attendance record, and view performance metric directly to the system portals. Next, let's talk about the data persistence. To ensure our data persists across system restart, the application reads from and write to a text file called attendance-data.txt. When the program in TLS, it first this command separate text file, which will represent a flat record containing the class type such as Java programming or database system, followed by the student type, ID, name, attended hours, and their specific subclass attributes. The system automatically instantiates the correct subclass object and populates them directly into the runtime memory. Our sample input instruction set pointing show exactly how this data is mapped when executing action in either like the lecturer portal or student portal, such as registering a new regular student like Faris Akmal from Selangor or an international student like Ahmad Iskandar. Now let's dive into the structured code implementation. Here is the source record for our abstract superclass student attendance. You can see the encapsulated private field and the constructor used to initialize common data. We implement fundamental method here like mark present and mark absent, which dynamically increment the total class session and attendance counts. We also calculate the basic mathematical metric using the calculate attendance percentage method. If we look at the subclass, regular student attendance handle specific constraints, warning the lecturer if a local student attendance drop below 80%. On the other hand, the international student attendance subclass handle a stricter threshold, triggering a critical visa review required warning if attendance fall below 85%, helping the institution comply with international student regulation. Finally, let's look at the implementation details of our aggregation class attendance list. As you can see in the code, the class manages a private class name and handles student profile. Using an array list called student record, we have a clean getter method get student record, which allows the main driver program to extract the list data and seamlessly save it back to our external text file. To populate this collection, the add student record method simply appends a student attendance object into the array list. The core logic rests in update student attendance. This method takes a student ID and a volume stat. It executes for each loop to find a matching ID, record the student roll metric, and then trigger either the mark present or mark absent operation. It immediately prints a comprehensive console set showing the name, ID, update counts, and the new left percentage change before returning true. The output data to the user interface display attendance list iterates through our array list and execute the override and generate status report method dynamically for every individual student. Lastly, calculate class average provide a high level performance matrix view. It sums up all individual attendance percentage using a loop and divide it by the total size of the record list.
For my part, I will briefly explain session 8.0, class application, by walking you through our code, followed by a live demonstration for session 9.0. As you can see here on my screen, our entire system is driven by this main class. It serves as the application central engine, bringing our object-oriented logic together through three main responsibilities. First, file I/O management, input or output management. If you take a look at line 7, we declare our text database attendance data types file. Down to line 15, line 16, load data from file, which automatically read this file when the program starts. Second, object aggregation. Right on the line 13, we institute our attendance list, class object for Java programming and database system. This object aggregate the individual student records using dynamic lists. Third, controller and interface. Starting on the line 21st, we use a while loop that runs continuously until the user chooses to exit. Inside this loop, around line 31, we use J option pane to capture the user numerical input, which is then handled by the switch statement on line 45 to navigate the system cleanly. Now that you've seen how the code is structured, let's run it for the live simulation. When the app starts, the main menu greets us. So enter the lecture portal, I will type 1 and press OK. I will type 1 to go to Java programming. And first, let's select option 3 to register a new student. I'm just going to do this quickly. It's going to be a regular student. Yeah, clicking OK dynamically builds the object and appends it into our array list. Next, open lecture portal again, some class, and type 2. Select option 2 updates the display with our class performance metrics, instantly showing individual attendance percentage and the overall class average. Now, type 1, administrative attendance override. The lecturer needs to manually change a record. Option 1 performs an attendance override by taking the student IDs and changing their status to true or false. So, sure, I'm gonna make this guy present. Now go back to the main menu, type super student portal. This allows students to perform a quick self-check-in. The student simply inputs their ID, choosing their class, and enter one to mark themselves present. As you can see here, I'm gonna do this. Let's go with database system. This guy gonna be present. Success, the update has been logged. So if you can go here, 3, view all transcripts. You can see all the information inside the class. Let's go with this, the one that I just add on. It's right there. And lastly, if we press 4, we save everything inside our database and the program has been running.
So, in conclusion, the student attendance system provides a simple and efficient way to manage student attendance by applying object-oriented programming concepts such as inheritance, encapsulation, aggregation, and method overriding. We successfully developed a structured and reusable Java application. Compared to the traditional manual method, our system reduces human errors, saves time, and automatically generates attendance report. We hope this project demonstrates our understanding of OOP concepts while providing a practical solution for attendance management. That's it. Thank you.